Okay, in this session we're going to discuss solving equations. Personally, I think it's useful that we all have a flow map or a process to follow that keeps us on track when dealing with equations. So what I've done here is provided a little process flow that I created, and it's basically called simplify, separate, inverse, isolate. Simplify, separate, inverse, isolate. Now, when we're talking about simplifying, we're looking for three things. We're looking to see if there's distribution within the equation, double signs. So here, I'll give you an example of distribution. If you see anything that looks like this, where you have some number or a minus sign right next to the parentheses, then that would just be an indication to multiply that number in front of the parentheses by everything inside. Okay, so that would be an example of distribution. Double signs, as you see here, double signs, you see a minus sign right next to a negative sign or a plus sign right next to the negative sign. All I'm trying to indicate is that those two signs simplify to become one. So in the event that you have something like 4 minus a negative 3, notice these two signs are back to back. There is no number in between these two signs. This is what I mean by double signs. So those two minus signs or negative signs, whatever you want to call them, can be simplified to look like this. So the two minuses become one plus. Alright, and just so you know, over here with the distribution, I didn't take it through, but if we have the distribution and we multiply, because distribution is just a form of multiplication, and we've talked about that in one of our previous lectures, then this would simplify to, 12x plus 8. The 4 times the 3x would give you 12x. The 4 times the 2 would be an 8. So this would simplify to 12x plus 8. And here with the double signs, this will simplify to just 4 plus 3, as opposed to 4 minus a negative 3. It just becomes 4 plus 3. Another example of double signs, let's say you have 4 plus a negative 3. Alright, again, two signs back to back without there being any kind of number or term in between the signs. So those two signs merge to become one sign, and it looks like this. So you would get a 1 here. Alright, so when you have double signs, the two signs that are back to back are opposite signs, it gives you a minus sign. When the two signs that are back to back are the same sign, it gives you a plus sign. Alright, so that's what I mean by double signs. Okay, over here still talking about simplify. The third thing we want to look for is like terms on the same side. So let's say I have something like 4x plus 3x minus 2 equals 7x minus 7. Okay, here you have your equation. Now this just says like terms on the same side, the key being same side. Okay, the key being on the same side. So now when I look at this, I see I have this 4x here. Well, I have a 3x as well, and I have a 7x. All of those are like terms. And I also have this negative 2 and this negative 7 as being like terms. Okay, but in step number 1, in simplifying, we're looking for like terms that are on the same side, and the only like terms that are on the same side when I look are these two. These two terms are on the same side of the equal sign. Here's the equal sign, so these two like terms are on the left of the equal sign. Alright, so they're on the same side, so I can combine them. So I just say 4x plus 3x would give me 7x, and I would just rewrite everything else that I did not touch. Okay, so that's what I mean by simplifying using like terms on the same side. Okay, okay. So picking back up where we left off, we said that you have your simplification, which is distribution, double signs, like terms on the same side. Okay, so now once you've looked at a problem and taken care of all issues regarding simplification, then you would look to separate the problem. So let's say you have a problem that looks like this. Okay, when you're trying to separate the problem, you see here I'm showing that you split the equal sign. Alright, so you find the equal sign and you split it. Okay, and again, all we're trying to do here is identify where the variable is. Alright, we're trying to figure out, is the variable on the left side of the problem or the right? Okay, and in this case we see that the variable is on the left. The reason this is important is because once we find or identify what side the variable is on, we understand that the goal is to isolate the variable or get it by itself. So if the variable is here on the left hand side and I know I want to get it by itself, then that means everything that's on the same side has to be moved to the other side of the problem. So that means this 3 would have to be moved as well as this 2. Okay, that's the only way this x will be sitting here on this left side by itself. Alright, now I also have a special note here under separate that says the variable on both sides move the smaller to the bigger. So let's say you have something, a problem that looks like this. Alright, so we've said we've gone ahead and done step number 1. We've simplified everything. So now we're looking at this. Step 2 says separate the problem. So I've separated it and asked where's the variable. Now I look. Now up here in this problem we saw that the variable was pinned down to the left side. Alright, so that's what we want. We want the variable pinned down to one side or the other. We want it either on the left or the right. Okay, but there comes a time when the variable may be on both sides. Alright, and before we can move from step 2, we have to get that variable, or we don't have to, but I recommend that the variable be pinned down to one side. So if I have a variable on both sides of the problem, what I suggest is that you move the smaller variable to the bigger. So in moving the smaller, I have a 3x on the left and a negative 4x on the right. So a negative 4 is smaller than a positive 3, so I want to move the negative 4 over to the positive 3 side. And I'm showing you that anytime you're confronted with this situation and you have to move the smaller to the bigger, then you're going to use either addition or subtraction. Well, we know anytime we cross this line, anytime we go across the equal sign, then we have to use the opposite operation, the inverse. So if I want to move this negative 4, which is smaller than the positive 3, then right now it's minus 4x, so I have to do the opposite of minus, which is plus. So I add 4x to both sides. So now the 4x cancels over here, and I have 3x plus 4x, which would give me 7x. Then I just bring down my 2, my equal sign, bring down my 6. Okay, alright, so that's how step number 2 works. Separate. Okay, and again, the goal in step number 2 is to make sure you have the variable pinned down to one side of the problem. So now once we move the smaller over here to the bigger, we now see that the variable is pinned down to the left side of the problem. Okay, alright, so moving on, step number 3, inverse, which I say is just another way of kind of saying this the opposite operation. This is where we start to move terms in order to get the variable by itself. Okay, so we have our variable. Everything's been simplified. I just separated. Here's our variable. So we have this 4 that we know we need to move, and this 3 that we know we need to move. Okay, because we can't get the variable, the x over here on the left by itself, until we've gotten rid of the 4 and the 3. So we ask ourselves, alright, we know we need to move the 4, we know we need to move the 3. Which one do we move first? Now I'm showing you here that we move terms detached from the variable. We move those first. Alright, terms that are detached from the variable. So what do I mean? Here's my variable this 3 is detached from the variable because there is a plus sign in between the variable and the number I want to move. Detached. Okay, so I want to move it first. So in other words, detached. There's a sign in between the variable and the number. There's a sign in between the variable and number. That's what I mean by detached. Alright, so I'd move this plus 3, and it says you move all detached using addition or subtraction. And again, if I'm going to cross over the equal sign, if I'm going to switch sides, then I have to use the opposite operation. So if it's currently a plus 3, then I say minus 3. So I subtract 3 from both sides. That cancels. So now I have my 4x equals 4 minus 3, which is 1. Okay. Still trying to get my variable by itself. Now I'm looking at a situation where I have it's separated. Here's my variable, and now this 4 right here is what I would consider attached to the x. Alright, there is no plus or minus sign in between the 4 and the variable we want to isolate. They're stuck together, they're attached at the hip. Okay, so anytime I want to move something that's attached, now I shift to using multiplication or division. Alright, so now currently 2 items next to each other, 4 next to an x, 2 things side by side represents multiplication. So to undo it, I have to divide. So I make my fraction bar, which is an indicator of division, and I divide by the number I want to move, which is this 4. So I divide this side by 4. Well, whatever I do on one side, I have to do on the other side. So now I'm left with x would equal 1/4. Okay, again, so now for attached, give you an idea what attached looks like. Side by side, one on top of the other. These are examples of attached. Okay, there is no plus or minus sign in between the variable and the number. There is no plus or minus sign in between the variable or a number. Alright, they're either side by side or one on top of the other. Okay, so the difference between detached and attached. Alright, now as you can see here, once we move the attached and detached, we have our variable is now over here by itself. It's isolated, it's by itself. So that brings us to our last step. We've gotten the variable by itself, and it is in positive form. Okay, the x is positive and is by itself. So this would indicate that we are now finished with the problem. Now, to give you some perspective on what I mean by the variable being positive, if you had a situation where you have a problem like this, step number 1 says simplify. There's nothing to simplify here. Step 2 says separate. Alright, so here's my variable. The number I got to get rid of is this 1 right here. So it's a plus 1. It's detached. This 1 is detached from the x, and it's currently a positive 1. So to move it, I do the opposite or the inverse operation. So I subtract 1. To subtract 1 from that side, I have to subtract 1 from the other side. So now these 1's cancel. I bring down the minus in the x, and 2 minus 1 just leaves me a 1. Now, this is a case where the variable is over here on the left side by itself, but it's not positive. That minus sign is still attached to it. So in this event, this would not be considered finished, because you have to get the variable isolated and positive in order to be complete with the problem. So in this instance, basically you could divide or multiply both sides by a -1, and it would change the signs. So if you multiplied or divided the negative x by a -1, it becomes positive x, and if you multiply or divide the positive 1 by a -1, it becomes a -1. So that would be your answer. Alright, so again, I have these steps over here as a way to try to help keep you on track. Okay, Some of you all may have learned how to solve equations and using other methods, and that's fine. But for those who may be a little weaker at performing this task, a little weaker at solving equations, I'm just trying to provide a format that'll help you navigate your way through various types of equations. Alright, so at this time, let's just take a look at some examples. Okay, start with some basic ones. Alright, let's start off with one like a -5 plus x equals 7. Fairly basic equation. Alright, so we check step number 1. Simplify. Any distribution in this problem? No. How do I know it's no distribution? Because distribution can only be done if you see parentheses in the problem. There aren't any parentheses in the problem, so I know there's no distribution. Alright, still on simplify. Now check for double signs. Are there any double signs? Do I see any signs back to back? Again, no. How do I know? Double signs also require parentheses to be in the problem, so no double signs. Alright, so last thing I want to look for in simplifying is like terms on the same side. I have this -5 and this +7. They are like terms, but if I look, I notice the -5 is on the left side of the equal sign and the +7 is on the right side of the equal sign, so they're not on the same side. So there's nothing to do here in step number 1. So now I can move step number 2, separate. So separate says find the equal sign, split the problem, identify where my variable is. Okay, so the good news is the variable is on one side. It's not on both sides, it's on one side. So since it's on one side, I can begin the business of trying to get it by itself. So to get this x by itself, I have to move everything that's on the same side of the problem as this x. Well, right now the only thing over here with it is this -5. Well, because the -5 is detached from the x, okay, I have to use the inverse or the opposite operation to move it, and the opposite of a -5 becomes a +5. Now again, once I do it on the left side to balance the equation, I have to do the same thing on the right. Okay, so the 5's cancel. I bring my x down since I didn't do anything to it, and then I have 7 plus 5, which equals 12. Alright, now I'm looking. My x is on the left by itself, and it's in positive form, so I have successfully isolated the variable, and as a result I am finished with this problem. So the solution to this equation would be x equals 12. Alright, let's look at one like this. Alright, here you have x over 7 equals a -2. Alright, so I look to simplify. There's nothing to simplify, so I separate the problem. Here's my variable. Okay, so in order to get the variable by itself, I have to look at what's on the same side of the equal sign as my variable, and right now it's the 7. Alright, so I ask myself, okay, is the 7 attached or detached from the x? In this case, this would be considered attached. There is no plus or minus sign between the variable and the number I'm trying to move. There is no plus or minus sign between the variable and the number I'm trying to move, so it's attached. Now if it's attached, I know I have to use multiplication or division. Well, currently it looks like a fraction, and a fraction is nothing but a form of division. So if I'm looking at something that's in division form currently, to undo it I have to do the inverse or the opposite, which would be multiplication. So I'm going to multiply both sides by the number I'm trying to move, which in this case is a 7. So I multiply both sides by 7. Notice on this side where I have the fraction look, I'm multiplying the x by the 7. I'm putting the 7 up top because the 7 over this 7 is how we get them to cancel. Alright, so I'm multiplying the 7 up in the top. So that allows me to bring my x down, and now -2 times 7 equals -14. I've moved my 7 by using the inverse, okay, and now my x is by itself and it's in positive form, so I've isolated my variable, so I have completed this equation. Alright, so those two are pretty basic, so let's try some that are a little more involved. Let's try 18x plus 9 equals -1 plus 8x. Alright, so I go through my steps, simplify, check simplify, nothing here to simplify, no distribution, no double signs, no like terms on the same side. So now, scratch through that one, move on to step 2, separate. Separate the problem, and again, when I separate, I'm trying to ask myself, where is the variable? Alright, well in this case, I notice the variable is here and here. So this would be an instance where I have variable on both sides. So here's our special note on how to deal with variable on both sides. So I move the smaller to the bigger. In this case, the 18x on the left, a positive 8x on the right. The 8 is smaller than 18, so I'm going to move the 8 by subtracting 8 from both sides, or 8x actually. So notice I didn't just subtract 8, I subtracted 8x from both sides to move the whole thing. So that cancels. 18 minus 8 gives me 10x, excuse me, positive 10x plus 9 equals a -1. Alright, so now I have 10x plus 9 equals -1. Nothing to simplify. Separate. Now my variable's on one side of the problem, so I can start moving things away from it to get it by itself. So I got to move the 10 and I got to move the 9. Well, which one do I move first? Well, I got to move this 9 first because it's detached from my x. This 9 is detached from my x, so I got to move it using the inverse operation. Well, currently it's being added, so I subtract 9. So now the 9's cancel. Excuse me. Bring down my 10x. -1 minus 9 is a -10. Divide both sides by 10 now, because the 10 is the only thing left to get my x by itself that has to be moved. So the 10 and the x are attached side by side, which is an indication of multiplication. So to undo multiplication, I divide, and I divide both sides by the number I'm trying to get rid of, which is 10. So x equals -10 over 10, which is -1. Alright, let's try another one. Let's look at this one. 6x minus 5x minus 1 equals 2. Alright, starting back over from first step, simplify. Is there anything to simplify? Well, okay, I see I have parentheses now, so that tells me to be looking for distribution. So I check. I see this minus sign next to the parentheses, and what you have to understand is this minus sign next to parentheses is like saying a -1. So really it's like saying there's a -1 right here. Okay, so you take that -1 and you multiply it by the 5x, then you take that -1 and multiply it by the -1. That would be your distribution. And when you do that, bring down your 6x, and then the -1 times the 5x would give you a -5x, and the -1 times the -1 would now give you a +1, and you'd bring down your 2. So you simplify the problem. So now you look at your new problem, your new equation, your simplified equation, and you check once again. Step 1, Can I distribute? No parentheses, so I can't. Are there double signs to look for? No parentheses, so that's indication no double signs. Like terms on the same side. Yes, I do. I have like terms on the same side right here. So I just say 6 minus 5 equals 1x. 6x minus 5x is 1x. I don't have to write the 1 in front. I just write the x. That means 1x. I bring down the plus 1 equals 2. Okay. Now, try to simplify. Have a new simplified equation. So I start back over. Step 1, simplify. Is there anything to be simplified? No. Step 2, separate. Split the problem. Find the variable. Variable is on the left side by itself. Well, not by itself, but it's on the left side. So to get it by itself, I have to move this plus 1. This plus 1 is detached, so I subtract 1 from both sides. Cancels over here. Bring down my x. 2 minus 1 is 1. My variable is by itself and positive, so I have finished. I have solved that problem. Okay, let's continue. See what else we want to do here. Any other problems? What would be a good one to try? Alright, well, let's look at a fraction problem. Okay, so let's look at one that's 1/3 6x minus 3 equals 1/2 8x minus 4. Okay. 1/3 6x minus 3 equals 1/2 8x minus 4. Alright. Now, here's the thing. If you notice, the denominator here on the left, this 3, actually divides evenly into the 6 and the 3 that's in the parentheses. So you could actually distribute the 1/3 into the parentheses on the left, and we can look carefully and see that we could do the same thing with the fraction on the right hand side. We could distribute the 1/2 into the 8x minus 4, because 2 goes in evenly into 8, 2 goes evenly into 4. But here's the thing, all problems won't work out this nicely. Okay, you may have something in parentheses that doesn't allow you to divide the denominator into those terms evenly. Okay, so instead of giving a bunch of varying scenarios to be looking for with fractions, I know most are uncomfortable with dealing with fractions in the first place, so let's just figure a way to get around having to deal with the fraction. Okay, so here's a little rule I came up with. Alright, and this will be a rule for solving equations with fractions. Okay, rule for solving equations with fractions. Alright, this will be a rule for solving equations with fractions. And the rule states, or as I see it, I would just say multiply everything that is not in parentheses I'm not sure if I spelled that right or not. Multiply everything that is not in parentheses by the least common denominator. Okay, also known as least common multiple, LCM. Okay, so the rule for solving equations with fractions: multiply everything that is not in parentheses by the least common denominator. By the least common denominator, or again, some of you may refer to it as the LCM, least common multiple. Alright, so let's look at our problem. We have the 1/3 times 6x minus 3 equals the 1/2 times 8x minus 4. Now, this equation has fractions in it, so we can look at our rule. Now, the rule says everything that's not in parentheses. Well, on the left hand side, that means this here, because it's not in parentheses. And on the right hand side, that means this fraction here, because it's not in parentheses. So it says multiply everything that's not in parentheses by the least common denominator. Now, looking at my denominators, I have a 3 and a 2. Alright, so the least common multiple for a 3 and a 2, or the least common denominator for a 3 and a 2, would be a 6. 6 is the smallest number that 3 and 2 both go into evenly. 6 would be the smallest number that 3 and 2 go into evenly. So what I would then do is multiply both of these fractions by 6. Now notice, when you're multiplying a fraction by a whole number, you just multiply in the top. Okay, just in the top. So when I multiply it now, it looks like this. Alright, but here's the thing. 6 over 3 is actually 2. 6 divided by 3 is 2. And 6 over 2 is really just 3. 6 divided by 2 is 3. Alright, so if you notice, what we've now done is taken the equation that we started with and turned it into a form that no longer has fractions in it. So something we're a little more comfortable with. Alright, so now we can again follow our rules, our steps for solving. And we see we have our parentheses, and we see these 2 and this 3 outside of parentheses. So that's just distribution. So you would distribute. You have 12x minus 6. 2 times 6 is 12. 2 times the negative 3 is a negative 6. Equals 3 times 8x, 24x. Minus 3 times the negative 4. Or 3 times minus 4 is negative 12. Alright. So it's been simplified. Step 2 says separate. Notice I have variable on both sides. So I move the smaller variable to the bigger. In this case, using subtraction. Bring the negative 6 down. 24 minus 12 is just 12. Keep my x. Bring down my minus 12. Now, my variable is pinned down to the right side. So I need to move everything from the right over to the left. So I have to move that over, and I have to move that over. And I start with this minus 12 over here because it's detached from the x. So I move it first. What I do on one side, I do on the other. Negative 6 plus 12 is a positive 6. Bring down my 12x here. Divide both sides by this 12. Since the 12 and the x are attached, that's multiplication. The opposite or inverse of multiplication is division. So I divide both sides by the number I'm trying to get rid of, which is 12. And now I notice I have x equals 6 over 12. Excuse me. Which reduces to 1/2. Okay? And there it is. You just solved it. Alright. Let's try another one. Okay. Let's try another example. Let's say 1/4 x minus 1 equals 1/3 x minus 4. Alright, again, a fraction problem, so we use our rule. Okay, but like I said, with the last problem, we noticed the denominators we had went evenly into the terms within the parentheses. In this case, it doesn't work. 4 does not go into 1x, 4 does not go into 1 evenly. 3 does not go into 1x, and 3 does not go into 4 evenly. So again, this is why we created this rule over here, because this rule allows us to deal with these varying scenarios. So it simply says if I have fractions, multiply everything that's not in parentheses by a common denominator. In this case, if the denominators are a 4 and a 3, then the least common denominator or least common multiple will be a 12. So I multiply the numerators of both fractions by 12. So that gives me a 12 over 4 x minus 1 equals a 12 over 3 x minus 4. 12 over 4 is just 3 x minus 1, and 12 over 3 is just 4 x minus 4. Distribute 3x minus 3 equals 4x minus 16. Variable is on both sides, so I move the smaller, which is the 3x, over here to the bigger, which is the 4x. 4 minus 3x is 1x, which is just x. Bring down to minus 16. To get the x by itself over here on the right side, then I need to get rid of this minus 16, so I add 16. Add 16, negative 3 plus 16 is 13. Bring down my x. X is by itself and positive. There's my answer. Okay. One last one with fractions. One last one with fractions to make sure we have a good feel for what we're trying to do here. So let's look at this one. Alright, so we have 1/2 x plus 2 equals 1/3 x minus 1/2. Again, equation with fractions in it. So the common denominator, I have a 2, I have a 3, and a 2 again. So the least common denominator, least common multiple for 2's and 3's would be a 6. 6 is the smallest number that 2 and 3 go into evenly. 6 is the smallest number that 2 and 3 go into evenly. So I multiply everything according to the rule. Everything that's not in parentheses by the least common denominator. So I'm going to multiply this fraction by 6. Notice I'm going to also multiply this whole number 2 by 6. Fraction over here by 6. Fraction over here by 6. None of the terms in this problem were in parentheses, so everything gets multiplied by the least common denominator, by the 6. Alright, so I have my 6 over 2x plus 6 times 2, which gives me 12, equals 6 over 3x minus 6 over 2. 6 over 2 is 3x. Bring down my 12. 6 over 3 is 2x minus 6 over 2, which is 3. Alright, nothing to simplify. Separate. Variable on both sides. Move the smaller variable to the bigger. So that 2x is smaller than 3x, so I move it. 3 minus 2 is x. Bring down to plus 12 equals a negative 3. Now I have my variable pinned down to one side, so I got to get it by itself. In this case, I have to move this 12, which is detached from the x. So plus 12 is moved by using the inverse, which is minus 12. Cancels. Bring down my x. Negative 3 minus 12 is a negative 15. Variable is positive, and it is by itself. That is your solution. Alright, so hopefully this gives you a little more confidence with dealing with equations. Again, some may have been taught using varying methods or different methods than the ones that I've displayed to you here, and if that's what you're comfortable with, fine. But again, if you haven't developed a good level of comfort with solving equations, I think what I've laid out for you in this session is at least a good place to start. So hopefully this helps, again, give you a little more confidence dealing with equations, and that will conclude the session.